Hi, I'm Chris Daniga with SwiftOtter, and you're viewing a video that's part of our free preview of our upcoming Magento 101 course. This is a course that's custom tailored for you if you're completely new to Magento and Adobe Commerce, and is going to provide a crucial foundation to walk you through the most critical aspects of development on the platform. So I hope you find the content in this video useful, and stay tuned for the release of the full course. We've done a lot of work so far with Magento's front end, working with layout and templates and even building our first controller, all in support of getting that initial submission form for product questions onto the product detail page. But we can't go any further with our feature without talking about the subject of data and working with database entities, because we need somewhere to actually save our product question. So we are going to take a step back from the work that we've been doing on our product detail page and just explore some of the foundational concepts of working with data in Magento. Managing data in the MySQL database using Magento's models is the kind of thing that you're going to do day in and day out in your development work, so it's important to get a good grounding on the general concepts that are involved here. The first thing that I'm going to do as we start to talk about this is just come in here into our module and create kind of a throwaway class here. And you don't have to follow along with this part. We're not going to do anything with this class. I'm going to throw it away when we're done. But I'm just creating a class here where we can actually see and visualize some of the syntax that we're going to be talking about. And the first thing that I want to look at just briefly is kind of the lowest level abstraction layer that Magento uses for making SQL queries. And that's going to start with a class. I will just start up a constructor here and inject a dependency here. It's going to start with this resource connection class. So this framework app resource connection class, we'll just call that resource. And really, it doesn't matter where I put this stuff. I'll continue to write this out in the constructor itself. So starting with that class, we can get an instance of a MySQL connection. Magento uses objects to represent potentially multiple connections to the database, but typically just one default connection. So we're just going to get connection there, and then that object is our starting point for where we could start to build manual query syntax using this abstraction layer that we're going to look at here. I'm just going to copy wholesale an example of this in here so that you can kind of see this. You see that we're using this expressive syntax here to call select off of that connection object that we got. That gives us a specific object that represents a query, and then we've got these methods chained onto it from with the name of the table. We're getting that table name from that connection object. The reason we do that is just because there is support for like a default table prefix that's used on all your Magento tables, and that avoids us having to hard code that if we are using this manual syntax here. But that from method is taking the table name and then a list of the fields that we want from the table. These other methods that we're chaining on here are putting a condition on our query with a where statement. Just note the placeholder in there that we're passing a value in for. So that translates under the hood in the kind of adapter that's being used, that object that's being used here into the prepared statements and the values that are bound into that. In this case, we're also chaining on this limit method that limits it to 10 results. And then ultimately, we're calling this fetch all method, passing in that select object to get the array, simple array of results that come back from that query. This object that we're working with, by the way, this connection object is this. Let's see, this adapter interface. That's kind of where everything starts with this abstraction layer and how we work with the database. There is a whole lot more that we could look at about the syntax of this layer here. There are methods for joining. There's a few different more complex ways to create filters like this one, and so on and so forth. Several other methods that can be used for more complex queries. As your development journey in Magento continues and you start doing more complex development, it's likely that at some point you're going to deal with this syntax, but this is as far as we're going to go with this layer in this course, because from here we are going to move on to a higher level of abstraction, which is the entity models and resource models that Magento uses to visualize data, and those are usually what we're going to be using to query data from our database and persist data into the database. Any particular database entity in Magento is going to have a set of 3 different model classes created for it that are unique to that entity. This is the kind of triad of models that you'll get used to creating again and again for your custom entities. There is the model itself, or the data model, as I'm going to call it, to distinguish it from the other two. So this is the actual relational object. It's stateful. It represents a record from the database, and when you're loading records from your database, what you're going to end up getting back is instances of your model. Then there's the resource model, which is treated as a singleton and is the actual class that's responsible for issuing the SQL queries for loading data or persisting data. And it's going to hydrate instances of that data model or accept a data model to persist into the database. And then we have the collection model, which is kind of a hybrid. A collection model represents a whole list of records, and like the resource model, it's responsible for issuing the actual SQL queries to load data, and then it's going to hydrate multiple instances of the data model to return that as the result of a query for multiple records. So these are the three classes that we rely on for dealing with data for an entity, and each of those particular classes has a particular abstract that it has to extend, which basically has all of the necessary built-in functionality. It just needs a table name and to know what column in that table counts as the primary key in order to kind of automatically wire up everything from there. You'll see that when we initially create these models, they're very lean. We basically just need kind of one initialization method call in each one to have the minimum class definitions that are required for us to use our models for loading and saving data. The first one from this triad that we're going to create is actually the resource model. Let's just close out that throwaway class that we had there. We'll probably continue to use that in this next couple lessons just to visualize some syntax, so I'm not going to delete it yet. But the models always follow the exact same naming convention that's really never deviated from. So in our model directory in our module root, we're going to create a subdirectory called resource model, and then within resource model, it's directly within that subdirectory that we have a class matching the name of our entity. So here in a moment, when we create the main data model, it's also going to be called post, and we're going to create that directly in the model directory. And like I said, this naming convention is basically universal. You're always going to use it. So we have this post class in our resource model directory, and we need to extend the correct abstract from the core. So we're going to extend abstract db. Let's see here. Here's the one we're looking for. So resource models will always extend that. You can see it's complaining about a method that we need to implement here, the construct method. So that is this method right here. Now, very important note to make sure that we're not getting things confused here. This is not the PHP native public constructor that we're looking at here. Notice the single underscore, and that this is a protected function instead of a public function. So this is kind of a confusing convention that Magento adopted, but this is a custom method that belongs to all resource models. In fact, we're going to implement one with this name in all 3 of the model types that we're going to create. Just make sure not to get tripped up thinking that that's the native constructor. And we just need to make one call in this method, which is this call to init that exists on the abstract. And for the resource model, init just needs to know the name of our table, which we called product questions post, and then it needs to know which column is the primary key, because it's going to use that to automatically populate the ID field on models. So this is all our resource model needs. With this wired up with that simple init call, we have a resource model that can be used to load up our entity. Next, we're going to create our data model. So again, directly in the model directory this time, we're going to create another class called post. This also needs to extend the appropriate abstract class from the core, in this case abstract model. Here we go, directly from the framework namespace here. And then we're going to similarly implement a protected function called underscore construct, just like we did in the resource model. And we're going to similarly call an underscore init method. In the case of the data model, the arguments that are expected here are a little different. The first thing we need is actually the class name of the matching resource model. So that's why we created the resource model first, is so that we would actually have this class name to pass in here. So just the class name of the resource model, and actually that's the only argument that gets passed in here to the init method for the model. This is still something that you're going to create on every model that you architect. I don't know that the model having a reference to the resource model is technically required for anything anymore. Data models actually have methods on them for saving, loading, etc., which call through to the resource model, but those are all deprecated. You shouldn't use them. You should use the resource model directly. I actually don't know if the reference to the resource model is still used for anything in the data model that's not deprecated, but nevertheless, this is the pattern. When we create our new model, we have that init call. So with these two models, the data model that represents an entity and the resource model that's responsible for managing it, we have enough where we could load single records and save records. To just kind of return to our throwaway class here to practice some syntax, let's just get rid of that, all these references to this resource class. And take a look at the syntax that we will commonly use to load and save our models. Let's look at saving first, because we don't actually have any records in our database yet. We would want to first of all inject in our resource model. This is commonly going to require some aliasing because both our models are called post. So we're just going to alias this as post resource and inject that in. And then we will also need a factory for our data model. So we've worked with factories a little bit before. Again, this model is a stateful class that is meant to be used for instances that actually carry state with them. So we don't want to inject those directly as if we're going to use them like a singleton. We want to inject a factory. Again, that's just appending factory onto the end of a class name, and that'll automatically generate a factory class for us. And we will inject that as well. Not sure why I'm bothering to initialize these properties since we're just practicing the syntax in the constructor, but that's my habit whenever I'm injecting things into the constructor. So the proper way to save would be to have an instance of our entity and then to pass that into the save method of the resource. So let's say we had a post that we created with this factory. So now we have an instance of our post model here, and data models extend data object. So we've talked about data object when we talked about block classes. Models extend data object as well, and that pattern of just kind of storing an arbitrary array of properties under the hood is basically used for the auto magic that happens when resource models translate model objects into SQL queries and vice versa, just automatically mapping the properties of the object with fields in the database. So when we have a post instance like this, we should be able to expect to we could set data like this, customer nickname. That's one of the fields that we had in our table, or using those magic methods can set customer nickname like that, and track those properties on our object, and just by virtue of that naming that matches our database table, when the resource model kind of processes this, that'll get mapped correctly. So we would set all our other properties here, and then our resource model has a save method that accepts a post, and that's how we would persist this to the database. So we can't really inject this class and use it anywhere that makes sense right now. But if we want to see this in action, there's a way that we can do this. And so this is where I'm going to introduce you to the tool N98 Magentron. So that'll be easy for you to find, and we'll link to it in the written material. I'm on the GitHub for N98 Magentron 2 here. And this is basically a CLI command that enhances Magento's native CLI capabilities with a whole bunch of other features. It's easy to install because basically you just download a single file PHP application, and in fact, presuming that you are using Den or Warden, N98 Magentron is already included in here. I'm SSH'd into my container here, and if we look at my user local bin directory, we already have N98 Magentron ready to use in this environment. So if I call that N98 Magentron command from my root directory of my project, looks like we have some cache that needs to be rebuilt with Magento. This, just like the bin Magento command, this will show us a whole slew of commands that can be used with this. The particular command that we are concerned with is this dev console command, which will give us an interactive console where we can just write Magento code and echo output and just kind of work with things in a little sandbox environment. So using this, we can put those models that we just created to the test and actually see them work without actually needing to inject anything in anywhere in our application at the moment. Now, the dev console from Magentron makes this DI variable available. That is an instance of the Magento object manager for fetching objects from the dependency injection system. We're not going to be creating a class where we have a constructor to inject dependencies, so we're just going to use this to manually get dependencies the same way we would injecting them into a constructor. So if we look back at this example code we were looking at, remember we injected a resource model for our post, and we injected a factory for our posts. So we can just use this object manager directly for both of those. If we say post resource equals, and we'll call this get method for the class, and then we will want a factory. And in point of fact, we could just use the create method from the object manager as well to directly create an instance of our object. Either way, we're just going to kind of do this the same way we would injecting dependencies into our class. Let's get a factory there, and we can just do in real time here what we were kind of looking at in that class. So if we create a post, and then we'll set some data on this and actually save it in our database. So we need to set at minimum, we need to set a product ID, a customer ID, the customer's nickname, and then the actual content for a question. And I'll just, in this case, we're manually setting IDs. I'll just make use of a couple IDs I know exist in my database. So on our post, I'll set a product ID of 1. I will set a customer ID of 1. Set customer nickname. We'll just go with Joe. and set content. This is a product question. All right, so we have this stateful instance that is now tracking all that data, and we just take that post resource that we fetched from the object manager here and save our post. And if our models are created correctly, then this should actually result in a record being created in our database. And there it is. And by the way, I'm using SQL Ace as my tool, my graphical tool for connecting to my database. You can use any SQL tool that you want. There are instructions in the Word documentation for the appropriate connection details if you want to use a tool like SQL Ace. Let's inject one more record in there. We'll set the same product ID. This time we'll set customer ID 2, different nickname, and we'll just say another question. And then make sure to save that object. All right, so we've got a couple records to work with in there now. Now let's look at the syntax for how we would load a record, and it's very similar. We're going to actually keep both our resource and factory dependencies, just as we kind of visualize this in a real class here. And the thing to note that might be counterintuitive with loading is we actually are going to instantiate a blank model before we let the resource model hydrate it. So we're not going to use a method directly on the resource model that will instantiate its own entity model to return to us. We are going to instantiate that right here. Whoops. And then pass it to the load model, or a load method on the resource model. And then that object that we passed in should now be hydrated with the data that came from the database. So right now we're just visualizing this the way we would normally write it in a class, but let's do that here in our dev console. So let's just to make sure, we will instantiate a brand new variable here from the factory. And then, obviously we have to have an ID to load based on. We didn't look at that in the syntax here. So we pass our object in as the first argument to the load method on the resource model, and then the ID value that we want to load, we would pass in as the second argument. And let's see, yeah, we just have IDs 1 and 2 right now. So if we wanted to load record 2, then it would look like this. There is a third argument to this method if you want to load by the value of some column other than the primary key. That's the third argument, and you have that flexibility. But let's just take here in the dev console, take our post resource and run load, passing it that empty object that we've created, and say we'll load from ID 2. And so if that worked correctly, we should be able to echo. Let's see, it was loaded post. This should be fully populated, so we should have a customer nickname. We should be able to call that magic method on the data object, and there's our nickname, Jerry. All right, so that's as simple as it is for how to just bootstrap our model and our resource model and use that for basic CRUD operations for our entity. There's also a delete method on the resource where we would just take a loaded model that we have and pass it to delete like this for deleting records. Now I want to make note of one thing here. I've been mostly using the magic methods that we've talked about from data objects as we're dealing with our model here, and we'll continue to do that when we start implementing some real code working with our entity. And you'll recall that that's something that I told you not to do. These magic methods aren't actually defined on the public API of data objects. It'll confuse your IDE, make code completion harder, and really we should always be relying on the public API of classes. So I recommended that you just go ahead and directly use get data like this. So the reason I'm using magic methods for now in this project is because eventually when you kind of graduate to the next level of working with your data, you should be implementing a service layer for your models, which is just something that we're not going to be doing in this course. And once you're at that point, your models really, you should be relying on the interfaces that your models implement rather than the concrete classes, and your interfaces should have explicit methods for getters and setters for your different fields. So we're just kind of using the same syntax that ultimately you should be using to work with your entities once you're using a service layer. Don't really want to get into the habit of using get data and set data here when that won't actually be the service contract that you're relying on ultimately. That just leaves one model left in our triad, which is the collection model. And once we have that, we'll have complete CRUD capabilities with our entity.